Anyone else? Any doubts and questions?
Sir, I have a doubt in HCV.
Sir, I have sent you on WhatsApp.
Okay, just now. Yes, Pratmesh, I've got your. Yeah, and who had the doubt in HCVs just now?
Hi.
हाँ बेटा, tell me which question from HCV?
Sir, 29.
29th. Okay, we'll go through that. Okay, so I'm starting with a couple of questions which Pratmesh you have sent. Okay, so it says thin uniform wire is bent to form two equal sides of a triangle AB and AC of triangle ABC, where their length is 5 centimeters. Third side BC is of length 6 centimeters. Okay, and that is made of uniform wire of double the linear mass density. Okay. So the distance of the center of mass from the point A. Okay, so let's understand this question. Just like this, let's say we have a triangle where these two sides are not only equal in length, but they are made of exactly the same material wire. So they're having the same mass per unit length or same thickness and same density like this. Okay. So this is side AB and this is side AC. Now we have the third side. Okay. Now this one is of double the linear mass density as compared to these two. And these two are of 5 centimeters length each, whereas this one is of 6 centimeters length. Okay. So you have to find the position of the center of mass with respect to the point A. Okay. So Pratmesh, anything you've done so far in this question?
Sir, I attempted the question before, but in between I was stuck, so I wasn't able to go forward.
Okay, okay. So see, one thing you can see is that this bisects this, no? So this is 3 and 5. So how much is this angle? It's cos inverse of 3 by 5, no? So it's 53 degrees.
Yes, sir.
Okay, that's one thing. Okay, so now let's say this side has mass m1. So its center of mass is over here. This side has mass m1 again. So its center of mass is here. Okay, and this side has mass m2, let's say, and its center of mass is here. Okay, so mass of AB is equal to mass of BC is equal to, let's say, some 5 lambda L. Okay, so let's take that as M. So in comparison, mass of side, sorry, AB and AC. Okay, what about the mass of side BC? It will be 6 in length and 2 lambda. Sorry, so this is 5 lambda.
What is 5 lambda L? Yes.
Yeah, sorry, my mistake. Okay, so this is 12 lambda in comparison. So if this is 5m, this is m, this will be how much? 12 by 5m. Right, this is clear so far?
Yes, sir.
Okay, so now what you can do is you can just make things a little simpler. You can take the point A as a sort of origin of our coordinate system, and with respect to that origin, you can place these masses, you can replace the rods AB, AC and BC with equivalent particles located at their center of mass. Got it, no?
Yes, sir.
So there is M1 located here. There is same mass M1 located here. And there is M2 located here. Okay. And now you know this angle is 53 degrees. You know this side is 4, this side is 5. So it's simple enough, no?
Yes, sir, I can do it now.
So first step, you can combine these two and place 2m1 here, and then combine this and this, and the center of mass will be somewhere in between. Okay, let's proceed with the next question.
So what question number was this?
By the way, this is from the module, no?
Sir, from an assignment.
Oh, this is from the assignment I had sent, no?
No, sir, from HP sir's assignment.
Okay, so this is question 18 from HP sir's assignment. Okay, what about the assignments I had sent earlier?
Sir, I've completed those.
You completed those now. Okay. Okay, I will also be sending you the answer key separately of the center of mass module, hopefully by today evening or by tomorrow earliest. Okay. So let's come to this question. Now this says there's a thin sheet of metal of uniform thickness, which is cut in a shape like this. Okay, so I'll make the diagram. So it's like a laminar body, okay, with a uniform surface mass density sigma, but the shape of the lamina is somewhat unusual. It's like this. So the shape is like this. If we draw a parabola y is equal to kx square, and then draw its mirror image on this side. So y is equal to minus kx square, and then just sort of cut it symmetrically like this. So you're getting this kind of a shape, where this is the line, the curve y is equal to kx square. And therefore, this is a curve y is equal to minus kx square. And this is x equal to a, this line. So you can say that, it's a laminar surface which is bounded by these three curves, y is equal to plus minus kx square and x equal to a, which is a straight line. So we have to find the position of the center of mass. Okay. Okay, so who's going to tell me how to do this question now? Do we see an
So
axis of, yeah, tell me better.
we can form some vertical strips.
Yes, why you've taken vertical strips and not horizontal strips?
So because it should lie on the x-axis.
Yes, very good. So first of all, you should recognize here that x-axis is an axis of symmetry. That is one thing we should recognize. And the other thing is that we have no option but to, so center of mass lies on the x-axis. It's, let's say, at xcm, 0. Okay. So xcm will be xdm divided by, in this case, I'll have to write it as integration dm. Like this, assuming there's some sigma. Okay. So here dm, because it's a surface distribution, it will become a sigma dA kind of term. But this dA, what we should take it as? We should take it as vertical strips or strips of length, let's say 2y and thickness dx. Okay. So that will look like a strip like this, which I'm drawing next.
So actually, sir, I think it should be this thing, horizontal strips.
Why?
So we'll have to integrate the COM of each horizontal strip, right?
We'll have to integrate.
COM of each horizontal strip, right?
So this is easier, na beta. Each vertical strip is like a equivalent particle on the x-axis, na? You understanding, na?
And sir,
Because
what
see,
will integrating
this point's coordinate is plus y, na? And this point's coordinate is minus y. Okay.
then?
And this is at x. Okay. So there's a relation between these two, and this thickness is how much? Dx. So it's easy, na? Now. Now see, if this has a mass dm, where is that mass of this thing center of mass located? At its x coordinate only, na?
Yes, sir.
Right, na? So it's easier, na, this way now. So this whole series of vertical strips, now we are replacing with a series of particles on the x-axis. Okay. So okay, now tell me how much will be this area of the strip?
Two y dx.
It's length into thickness. No? So we'll take that as 2y into dx. And now we'll use that relation that y is equal to kx square. So it is 2kx square dx. That is the thickness of, that is the area of the strip. Okay. And we'll assume some uniform sigma. So now what is happening? This integration dn will become sigma dA is integration. So that will become sigma into 2 into k x square dx integrated from x equal to 0 to x equal to a. And the numerator's integration x dm, just add an additional x to the whole thing. Inside the integration, multiply with an additional x. So anyway, so what is the first integration giving me? It is giving me 2 by 3, right? Sigma k into a cube. So what will this give me? It will give me 1 by 2 or 2 by 4. Sigma k into a to the power 4 ho jayega, right?
Yes, sir.
This be x cube dx integrated from x equal to 0 to x equal to a. So this will give me 1 by 2 sigma k a to the power 4. So from this I can now see that the x coordinate of the center of mass is the ratio of these two things now. So it will be 1 by 2a to the power 4 divided by 2 by 3 a to the power 3. So x coordinate of the center of mass is going to be 3 by 4a and y coordinate of the center of mass is 0. So this is the position of the center of mass for this. So this is definitely a very, expected sort of question at JEE Advanced level. Because while there is integration, but it's not that lengthy or anything, to just pick up the symmetry of the situation. Okay, hope this question is clear to all of you.
Yes, sir.
Okay. So Pratmesh, there's one more question you sent. We'll finish that. Then we'll come to HC Verma question 29.
Sir, not 29, 38. Sir.
Sorry, which one, beta? 30?
38.
38. Okay, we will discuss. And I have got some more questions. Okay, so let's do the next question from Pratmesh. This one is like this. Two particles of equal mass have initial velocities given in I cap J cap form. First particle has an acceleration of this much, while the second particle's acceleration is 0. The center of mass of the whole system moves out. Okay. So this is also an interesting type of question. Okay, so it says that two particles have same mass. So let's say this is A and this is B. Now we don't know where they are initially, but it doesn't really matter. We have to only find the trajectory. Now A is having an initial velocity of 2 I cap and B is having an initial velocity of 2 J cap in meters per second, and A is having a uniform acceleration of I cap plus j cap in meters per second square uniform, whereas B is having an acceleration of 0. It's moving with uniform velocity. So we have to comment about the trajectory of the center of mass, is what kind of path it moves. So the options given to us are circle or parabola or ellipse or straight line. So what will be the general method of doing this? To understand the trajectory, we have to do what? We have to find xcm and ycm as functions of time
Yes, sir.
and then eliminate time. To find sort of y as a function of x, or at least a relation between y and x. So do that only now. Now you can understand that what kind of path the particle A is having. What kind of trajectory particle A will have? Can you tell me? Uniform acceleration, right?
Yes, sir.
And what about the initial velocity? Is it collinear with the acceleration? No, no, non-collinear.
Yes, sir.
So what kind of path it will have? Parabolic path?
Sir, I don't know how you're doing that.
Yes, sir.
You have seen the example of this, no? Projectile motion. Projectile motion और vertical motion में क्या difference होता है? Both have uniform acceleration, but in one you are projecting with a velocity which is collinear with the initial velocity. So it's a straight line motion with uniform acceleration. In the other, you are projecting with a velocity which is not parallel or anti-parallel. No?
Okay, sir. Okay.
So got it? No? So you just relate it with that. No? So that's how, of course, we'll write the equations and understand that. Okay, but that you can relate and directly understand. No? कि इसका path parabolic होगा, whereas इसका path कैसा होगा? Straight line होगा. Okay. So anyhow, so let's write this now. So can you tell me directly what will be A's displacement as a function of time? Just use component algebra, ut plus half at square along each of the axes, isn't it?
Yes.
So what will it be? 2t plus 0.5 t square I cap, right?
Yes, sir.
And 0.5 t square j cap.
Yes, sir.
So indirectly you can see here, that it's going to be a quadratic relation between x and y of that type. But anyway, we have to look at the center of mass's trajectory, not A and B's trajectory individually. So this part is clear so far. A and B's trajectory we've got.
Yes, sir.
So from this, what we can say about center of mass's trajectory? SCM is going to be, in this case, they are equal masses. So it's going to be arithmetic mean of these two. No? Okay. So it is going to be t plus 0.25 t square I cap. Okay. And t plus 0.25 t square j cap. Is this correct? Just check.
Yes, sir.
Okay.
Yes.
So now you can see which is this. This is the line x equal to y. Just observation. At any time, the x coordinate of displacement is equal to the y coordinate of displacement.
Yes, sir.
So it's a straight line making an angle 45 degrees with the x-axis. Okay, next we are going to do these questions from H.C. Verma. I have received some more doubts also, so I'll just go in order. Question 24, then question 38, and then question 40. System of particles, H.C. Verma. If anybody else has any other doubts in H.C. Verma, please send me now itself. so that
Okay,
we
sir.
can do all the H.C. Verma questions together in one shot first. Okay. And go through question 24. We're going to discuss that next. Okay, we'll add question 57 also. Okay, 52.
Sir, I've sent my doubts in chat.
Okay, Janvi, these questions are from H.C. Verma, no?
Yes, sir. So,
Okay,
but the
so
last that I've sent you, they're all similar. So even one solved is fine.
okay, no problem. We'll start with this then. Okay, so let's go through some more of these questions. 4, 10, 12, 13. Yeah, they're similar questions. We'll see. Okay, so anyhow, since said question 24 earlier, let's start with this. Then we'll come to these ones. Okay. All right, just a moment. Okay, so page 161, I think mostly.
Yes, sir.
Yeah. So question 24, which is during heavy rain, hailstorms of average size given to us in diameter. So assume they are like spherical. No, you know what a hailstorm is, no? All of you.
Yes, sir.
Yes.
Because Mumbai doesn't have hailstorms, so it's like questionable whether you. So it's basically like ice, small pieces of ice. Sometimes they can be pretty large also. Like in North India, sometimes you have rarely, but you have hailstorms where large chunks of ice big enough to break the windshields of cars and all fall from the sky directly. So you can read up what creates hailstorms. It's a very unique set of events where moisture clumps up into ice blocks as rainfall happens, rather than snowflakes. There are two different situations. What creates snowfall versus what creates a hailstorm. So anyway, coming back to this, during a heavy rain, hailstones of average size 1 centimeter diameter fall with an average speed of 20 meters per second. So also unlike rain water droplets, which achieve terminal velocity by the time they reach the ground. So we assume that they move at uniform velocity. Hailstones, which is basically small stones of ice, don't have that kind of motion. The air resistance force is far less in comparison to what it is on water droplets. So they don't really achieve terminal velocity. They are moving with acceleration by the time they hit the ground. So that's another reason why they hit the ground much faster. compared to rainwater. So anyway, so 20 meters per second is the average speed. Suppose 2000 hailstones strike a surface per square meter of 10 by 10 per second, and they do not rebound. So we have to calculate the average force. So basically this is like, we calculate the collision impulse per square meter, assuming that the collisions are perfectly inelastic because they're not rebounding. Okay, and the roof size is given to us. Okay, so let's look at this question in detail. Just a moment. Hello.
Hi.
Okay, so all good now?
All
Okay.
good.
Chalo, I'll call you back then. I'm in lecture. Huh?
Yeah, bye.
Yeah, so question 24, something like this is happening. So imagine you have a square roof which is of side length 10 by 10, and on this hailstones are falling such that on an average a hailstone hits the roof with a speed of, so I'll also make a two-dimensional diagram here. So the average hailstone hits this with a speed of 20 meters per second and then makes a perfectly inelastic collision. So can you tell me how much will be the impulse that each hailstone applies? So a single collision results in a collision impulse of how much? M into V naught. Okay. So how will we calculate the M over here for this question?
Sir, with the density and volume given.
Yes, you have to use the standard value. Achha, density of ice is also given. Otherwise, you'd have to. Okay. So we'll take this as density of ice as 900 kg per meter cube. So that is basically 0.9 gram per cc. And the volume of a hailstone will be 4 by 3 pi r cube, where r is given to us as 1 centimeters.
Sir, so here size refers to the diameter or the radius of the hailstones?
Size is, I think, given as diameter. No? So we'll have to half that. So 1 by 2. Okay. Fine, no?
Yes.
Because given to us is diameter, which is 2r, 1 centimeter. This is given. Okay. So this is the, so I'm not doing the full calculation, but okay, this is the impulse due to a single collision. Now we have to calculate what the average force that is acting on this now. So that force will be basically equal to what? It will be number of collisions per second into impulse in each collision. Understood? No? Because this impulse will be in Newton second and this is per second. So that is what will give us force in newtons. Okay. So now what all information we are given? We are given this area. Okay. And we are also given that what else we are given? The number of strikes per square meter per unit time. So it is given that the hailstones which are falling, there are 2000 strikes or collisions per meter square per second. So what will this term become? Number of collisions per second will become 2000 multiplied by that area. So that into J will become our force. Okay. So L is given as 10 meters. So this will become 2000 collisions per meter square into 100 meters square. So many collisions per second. Okay. Into the impulse because of each collision, which will be 900 kg per meter cube. I'm doing everything in SI unit now. Into 4 by 3 pi into 0.5 into 10 raised by minus 2 whole cube. Okay, so this is whole thing is in kg into v naught, which is 20 meters per second. So kg meter per second or Newton second. So this whole calculation now will give us the force in newtons. Okay, so hope this question is clear.
Sir, I did this only, but the answer doesn't match.
Answer doesn't match. Is it like a difference of order of magnitude or value?
The order of magnitude.
Okay, we can check it out. So let's do a quick calculation. So 9 into 2 into 4 pi by 3.
Firstly, it was even 1 centimeter, not
What
1
was
meter.
the
The
what was the-
radius.
हाँ तो बेटा वो किया है ना
Oh,
1
no,
centimeter
but the
1
right answer.
centimeter ना
Oh, yes, sir. You
हाँ so I have taken that.
10
Okay.
raised to minus 2 you took.
So 0.5 cube will become 0.125.
So the answer comes right. I thought I got it wrong. Right.
Okay. So you are getting a difference in order of magnitude, whereas the numerical
sir.
answer was correct. ऐसा क्या?
No, sir, proper. I'm getting the right answer. I remembered wrong.
Okay. You will get in this. So you just be patient. But anyway, it's a lengthy calculation. Okay, now let's come to some of the early questions in HC Verma first. Come back to the C. So question 4 and 10. Let's look at these two next. So if you're noting this down, do that while that others please go through question number 4 and 10.
Sir, I didn't understand the meaning actually of question 4.
Okay, let me explain. So uniform disk of radius r is put over another uniform disk of radius 2r of same thickness and density. Okay, such that the peripheries touch each other. So this is a superposition type of question. Okay, so
Sir.
just yeah.
How can the peripheries touch each other? They have different radius.
So that only no. At the periphery, at a single point, they are touching each other. Understanding the point?
Oh, okay,
Well,
sir.
so now you can do this now.
Yes, sir.
Just imagine you put the second disk on top like this, such that at one point on the periphery they are touching.
Okay, sir. Okay.
Okay, so this is a superposition question. So complete that now. Okay. Both are made of the same material and same thickness. That means they'll have the same sigma.
Yes, sir.
So their masses will be in 4:1 ratio because their radii are in 2:1 ratio. Okay, let's look at question 10 next.
Sir, here also.
10th is slightly tricky question, Yeah.
If there is
The
no
logic
gravity, why will it descend at all? Even if it melts.
Yeah, so if there is no gravity now, that cube will remain, that block of ice will just remain the same. The difference is that its density would have changed, so its dimensions would have changed. Density of water is more than density of ice, no?
Yes, sir.
So it would have compressed slightly. Okay, so let me explain. So the tricky thing is that this is in a gravity-free hall. So in fact, let's do one thing. Let's discuss question 10 in two contexts. One is that suppose there was gravity, but then this thing could not be floating now, so it doesn't make sense in the question. Okay, so we have to take this as a gravity-free case only. Okay, so now see, first of all, it's a logical question that your system is in a gravity-free environment now. While this sort of thermodynamic change is happening, that ice is melting. So this is a 0G environment. And on that we have a tray. And on that tray we have an ice block. like this initially. Okay, now it says by the time the ice melts. Okay, the question is asking that if the ice melts, by what distance does the center of mass of the tray plus the ice system descend? So we can answer this question without doing any calculation or without thinking of anything like that. Just answer the question, the tray plus ice as a system, what is the net external force on it?
0.
0, no? So, and what is its initial momentum? 0. So its momentum has to remain 0. So that means the center of mass cannot move, no?
Yes, sir.
So what happens here is that because you are in a 0G environment, as the ice melts, it will compress a little bit. So it will form water, which is like this, let's say. So in that sense, if you assume that the tray remains stationary, then the center of mass of the ice would have come down. But what will happen? The tray will compensate and go up. And that will happen because of the mutual changes that happen between the ice versus water versus the tray. There will be some kind of interactive forces between them, which will force this change to occur.
So the ice will compress.
Yes, because density of water is how much? 1 gram per cc, no?
Yes, sir.
And density of ice is, now this is very hard to imagine because one would think that when ice melts, it should just form a layer of water here. But remember, it's a 0 gravity environment. So no layer of water will form. Okay. And in fact, those of you who have studied surface tension a little bit, you will realize that even that will not happen. Actually, what will happen is as the ice melts into water, it will form a solid sphere of water because of the phenomena of surface tension.
Yes, sir.
But it doesn't matter what shape the water forms and all that. Okay. The thing is that on the whole system, the net external force is 0. And initially the system was at rest. So the center of mass was at rest. Okay. So the center of mass remains at rest. Individual parts just compensate for each other. So
Okay,
this is just one of those, slightly tricky conceptual type of questions, but you have to just stick to that basic idea that if the center of mass moves, that means it has to develop some momentum. So that means there has to be some net external impulse, which is not happening in this case. Okay. Right. Let's come to the 12th question next. What is the 12th question now?
Sir, I solved the question, but I just had some trouble understanding how this thing.
Is it that balloon wala question? No. Which question is 12th?
No, sir.
now?
The 2 men
The
moving in a
balloon
boat.
is 14th.
Okay. Yeah. Acha, 2 people walking.
Yes,
50
sir.
kg, 60 kg are sitting at the 2 extremes of a boat to discuss a mechanics problem. They come to the middle, neglecting friction. How far does the boat move? Okay, so tell me a bit of what is the question problem in this question?
If there is no friction, then why will the boat move at all?
Why will the?
Boat move.
Because the people, see, there's no friction from the water below, but the people are able to walk on the boat because there is friction between their feet and the boat surface, no? Understood, no?
Okay, sir. Okay.
No, so see, this is, let's say, the boat surface. Okay. Now, if this guy walks forward, so he is applying a backward impulse on the boat, no?
Yes, sir.
To generate a forward impulse on himself. So if he has a forward displacement, the boat has to have a backward displacement to compensate.
But sir, that impulse also will depend on the time, no? The time taken.
No, so see, again, walking is that very strange kind of situation I told you. Walking involves forward and backward impulse. Like when your back foot is pushing against the ground, you accelerate forwards. Then when your front foot hits the ground in front of you, you decelerate, no? To stabilize yourself.
Yes, sir.
So it's that kind of process, no? Continuous backward, forward. But in the process, what is happening? This mass is displacing. So this mass has to displace because on the whole system, the net external force is 0. The momentum of the system is 0. Okay, so the center of mass's velocity has to remain 0.
Yes, sir.
So displacement of center of mass has to remain 0. No? We don't need to worry at the micro level that with each footstep what is happening and all that. We just need to see that, okay, after some time, if the person, now I'm taking, so this is what 60 kg, this is 50 kg, let's say, and the boat's mass was given, or
Sir, I've solved it actually. I got the answer also.
so
I
you
just
understood now? So what is happening now? We look at it like a closed system, no? So obviously after some time, if this mass has reached forward, this mass has reached backward, the boat would have moved backwards, no?
Yes, sir.
That the center of mass of the system, wherever it was here, it remains here only now.
Sir, another thing, if this was a crawling case, they were not walking, then the
I
boat
mean,
would
what's
not.
the difference between walking and crawling in that sense? They are both slow, no? Slow processes.
But in the crawling case, we don't really take any forces on them. No, we say okay, no friction.
Why? How can something crawl without friction? Tell me, beta.
Sir, I don't know, sir. I was told that whenever crawling is given, you have to take it as a case where there's no friction considered.
No, that is not good. See, there are only the thing is what you have to understand, na, that see the difference is on a surface. Now let's forget about this center of mass and all. Let's just talk like this. On a surface, if a person starts moving, so there are 2 or 3 different situations you can consider. Suppose you're considering the initial part of his motion. He was at rest initially, and after some time you see him running at a constant speed v. So to go from here to here, he would have had acceleration.
Yes, sir.
Okay, but you'll realize that that acceleration can't be a uniform acceleration because it's not a machine. No? You can see an average acceleration. So how that average acceleration is occurring is because every time his back foot is pushing against the ground backwards, he's having some forward acceleration A1. Then every time his front foot is hitting the ground, he's having some reverse acceleration A2. But A1 is greater than A2. So overall, he's having an average acceleration in the forward direction.
Okay, sir.
Understood? No? And that is generated by friction. Now, once he reaches his velocity, which he wants to continue with, he will adjust his muscular motion in such a way that A1 and A2 balance. No? So average acceleration becomes 0.
Okay, sir. Okay.
And then later when he wants to decelerate, the reverse. Now, he will adjust his motion in such a way that A2 dominates over A1. And over a period of time, he is able to decelerate from V0 to 0.
So in the next question also, actually, I don't understand how the bob will reach that slot.
Okay. That's the 13th question, no?
Yes, sir.
Okay. So in 13th question, you have to consider, I mean, there are little bit of imperfections in every surface now. If the surface was perfectly horizontal, so let me just put up the diagram. So these questions from HC Verma like really force you to think little bit like out of the box. Okay. And sometimes it's not so convincing also.
It's just about putting the formula in, right?
More than that, you know, it's about like what assumptions you can make and what assumptions you cannot make. You know? Like you might say that, okay, in this question, we are making a certain assumption which contradicts an assumption we had made in some other question. So in that sense, now you can say that the questions are little.
Sir, otherwise it's just the comp formula question directly.
You can see, you can think in one way that what is the whole point of the question and what is the data available to us. So what formula we can use. That's one way of solving the question. That you just say that, okay, this assumption we have to take because without this assumption, we can't solve the problem.
Oh, yes, sir.
So that is one sort of logical approach you can take. Okay. Now, yeah, I understand what you're saying. So the mass of the cart is given, the mass of the bob is given. Okay. And the horizontal distance between the string and the slot is L. Okay. So now what you are asking probably is that if the string breaks, okay, why should the bob at all reach the
Yes,
slot?
sir.
You know, what should happen is that either it makes a perfectly inelastic collision and sticks here. Okay. Or even if it makes an inelastic collision, it bounces, and eventually comes to rest here. There's nothing to suggest that the bob should move horizontally. Okay.
Yes, sir.
But that is assuming a perfect situation where this is a perfectly horizontal plane surface. So it applies an impulse like this on impact. Okay. Now what HC Verma is doing here is it's saying that if there is a slot in between here now, on a surface, there will always be some kind of this thing, the surface won't be perfectly horizontal if you look at it at a more magnified level. So as it bounces, it's likely to go back forth like this, but eventually it's likely to find that position at which it has maximum stability. So that is where its potential energy is minimum.
Okay, sir.
You're understanding the point? No? Think of this like a practical situation. No? It's actually the floor of a bus. So there's no way you can design it in such a way that it will be perfectly plain. No?
Yes, sir.
You would have to use very, very expensive equipment for that, which is not practically going to be the case. So if there is some portion in the floor of the bus, which is like having a depression like this slot over here. So any object which is continuously bouncing, and assume, now see, the other thing is you're assuming that it does not lose too much energy while bouncing. So that's where it becomes strange. One assumption you're taking sort of ideal, the other assumption you're taking non-ideal.
Sir, I get it.
So those ways this question is a little strange in that sense. Okay, because if you really start thinking practically, there are several reasons why this bob could reach the slot, but there are also reasons why this bob may not reach the slot. If the surface has too much friction, then somewhere or the other, as it's bouncing and rolling along, it will stop before it reaches that maximum stability point, right?
Yes, sir.
So anyway, so that question has to be done with that proverbial pinch of salt. Okay.
Okay, sir.
Yeah. 14th question has a different concept to it. Oh no, 14th is at monkey problem. Okay. So do we need to discuss this question also, 14th one?
No, sir.
Okay, so this is also clear. Okay. What are we doing next?
Sir, I have sent you a question. Oh,
Yeah.
we are still doing it, sir.
Yeah, we still, let's finish doubts of HC Verma first. So I think we had all these questions. 14th is done, 24th is done. Let's come to 38 next. 38, 40, and 52. Let's complete these three. Okay, so I'm going to question 38 next. Okay, yeah, so here I think we have to make some kind of a series, if I'm not mistaken. So two friends, each of 40 kg mass, are sitting on a frictionless surface. Okay, and there is at some distance d, a ball of mass 4 kg.
Sir, A rolls a ball.
A rolls a ball towards B. If B catches, B rolls it back and all this. So this back and forth motion of the ball happens in such a way that the ball has a fixed speed of 5 meters per second on the platform. So it means with respect to the platform, and the platform is fixed. So it's with respect to ground. So find the speed of A after he rolls the ball for the first time, which I'm sure you worked out. Find the speed of A after he catches the ball for the first time. Okay. After he has made 5 round trips. And how many times can A roll the ball? Okay. So how many times you'll realize once we start working on this kind of series. Okay. So let's see what happens. And you can say the first round trip of the ball. First round trip means A has thrown the ball, then B has caught it, then B has thrown it, and then A has caught it again. So let's see what's happening in that first round trip. So at the start of this round trip, everything was at rest. Mass of A is equal to mass of B. And mass of the ball is 4 kg. And the velocity with which the ball moves is 5 meters per second with respect to ground. So first event, what happens? A chucks the ball towards B at a speed of 5 meters per second. So what is the impulse that A will experience? Okay, from that we'll calculate the velocity. the impulse that A will experience in the backward direction will be mass of the ball into V. So that will be 20 Newtons second. So as a result of this, if we say A's velocity is now V1, so V1 will become 20 divided by 40. So that's 0.5 meters per second. Next event, what happens? B catches hold of the ball. So when B catches hold of the ball, B plus the ball develops some velocity, let's say V prime. Okay. So for this event, what is happening? mv is equal to m plus mass of B into V prime. Okay. So this this momentum of 20 is now distributing into 44 V prime. Just a moment. Okay, so now see, from this we can understand one thing. How much impulse is acting on B when B catches the ball? So that will be this, no?
Yes, sir.
Into 5. Okay, is this calculation correct? No, 40 by into 20, my mistake. Okay. Is this clear, this calculation?
Yes, sir.
Okay. Now, next up, what happens when B throws the ball? Now his velocity, let's say, becomes V double prime, and the ball is coming back at 5. So in this event, how much impulse is acting on B? Again, J only, no? Because he's delivering that much momentum to the ball. Is this clear? I mean, is this correct, first of all? Is this
Yes.
J the same as the first J that A has experienced, or is it different?
Sir, it's different.
It is
Impulse are
different.
here.
Why it is different? Because
Sir, actually the magnitude of J will be the same. The effect will be different.
no, will the magnitude be the same? See, when A threw the ball for the first time, the ball changed momentum by how much? By 4
By-
into 5, na? Because it went from rest to 5. What, no?
Yes, sir.
But when B throws the ball, its velocity is V, but its momentum is changing by how much? V plus V prime into M, no? Got it, no?
Yes, sir.
Yes, sir.
So this impulse is now becoming how much? It is becoming M into B plus V prime, no?
Yes, sir.
Got it, no? So it's becoming like this. 5 plus, now what was V prime?
20 by 40.
0.5.
20 by 44. Okay. Okay. Now come to the impulse that A experiences when he catches for the first time. So for this process, A experiences an impulse J2, let's say. Okay, this was J1, let's say. So let's look at A series again. So for A, the first impulse was 20. Okay, second impulse we'll calculate. Whereas for B, the first impulse was 40 by 44 into 20. And the second impulse he experienced was like this. Okay. Okay, now tell me how much will be J2? So for that, we'll have to calculate this V2,
Yes, sir.
right? So capital M V1 plus small m V is equal to M plus M V2. Okay. Now capital M V1 was how much? It was equal to small m V only.
So why did we calculate J double prime?
So that we know na, that we are not doing this calculation for B, but okay. See, what we have to understand is like what kind of series this is forming na, of the impulses. Then we'll know that with each iteration, how the velocity of A and B is increasing.
Okay, sir.
So we'll try to make a general form of the.
We'll try to
after
make a
M.
general form, okay.
Okay.
And then when this situation will stop happening, when one of their velocities becomes more than 5. Because with each time they're throwing the ball now, the velocity is increasing.
Yes, sir.
Each time they're catching also the velocity is increasing, and each time they're throwing the velocity is increasing further. But when they throw in the opposite direction. No?
Yes, sir.
Okay. Now what will happen? A's velocity will always be more than B's. Because A was the first guy to receive an impulse, no?
The A was the first one to
Receive
yes,
an
sir.
impulse. Because the motion started with A, no?
Yes, sir.
So at any given point of time, no, A has had more number of impulses acting than B.
Yes.
So
More
A's
than or equal to.
velocity will have a larger magnitude always. So which one's velocity will become more than 5 first? A's velocity will become more than 5 first.
Yes.
So the last time somebody throws the object will be who? It will be B. At some stage, B will throw the object back at 5, but by then in the collision before that, when A had thrown it towards B, let's say at the nth time, A's velocity becomes more than 5. So this time A cannot receive it back from B.
Yes, sir. I think that's what they're asking in the date part of the question.
Yes. That is what they're asking, that, when they're asking that after what is the D part now, if they're asking how many times can A roll the ball. So that is only this stage. Okay, so what you'll see that after the first time A rolls the ball, A's velocity becomes how much? It becomes this 20 divided by 40, so 0.5. Then second time he throws the ball, when we complete this cycle, we'll see how much his velocity becomes. Third time we'll see. So there'll be a pattern that forms like a series. So we'll be seeing that after certain number of throws, A's velocity becomes more than 5.
Yes.
Right? No? So this question requires a bit of patience, but you have to solve it that way, no? Event by event. Okay. So give it a try from this point, right?
Then I'm actually not able to visualize why a pattern will be formed.
Okay. So let's see that now. That is what we are doing here, no? But we have to continue that series now. Okay. So now tell me, or let's just calculate V1, how much V1 was after the first time A threw the ball. So it was 0.5.
Yes, sir.
Now, how much will be V2 that will come from here? So let's do this calculation. So this is 20 plus 20, 40 divided by 44.
Yes, sir, I got the series.
Hmm.
So V1 is just the second last term, the velocity before pi. That's V1 we will take, and the final velocity will take more than 5 V2
Hmm.
term minus second last term, something like that.
Okay, but what is the series pattern that you're getting?
So that only I don't really get.
Okay, so anyway, let's look at this. Now for B on the other hand, what is this V prime coming to? (20/44).
Yes, sir.
And then what is this V double prime? Anyway, so for B, we don't really require it. We'll concentrate on A. So now third time A, I mean, after this, when A throws the ball again, how much his velocity will become? So we'll have to use this momentum conservation again, that A plus the ball, we're going at V2. And now A has a velocity V3 and the ball is going back at V. Okay. So 44 kg into V2 should be balanced by 40 kg into V3 minus 20. Okay, so we should be able to form some kind of a series. That's what I'm trying to do. Okay, so let's try this again. Let's just concentrate on every time A throws the ball, what's happening. Okay, because we know it's coming back at 5 only, na? So we don't need to worry about what is happening to B. So first time A throws the ball, so this V1 is 5 into 4 divided by 40, 0.5. Okay, then A catches the ball. So he's going at V1, the ball is coming back at 5. So this is all A. So A plus the ball have a common velocity V2. So what is happening? This capital M V1 plus small m into V is becoming capital M plus small m into V2. So 20 plus 20 becoming 44 V2. So V2 is becoming 40/44. But if we think of it like this now, what is the change in momentum of, because I think we have to understand it in terms of impulse. That is the easier way. So this time A was receiving an impulse of mv. Now A is receiving an impulse of it still become more complicated. Okay, so let's see. Now when A throws the ball, his velocity becomes v3. So m plus m v2 should be equal to m v3 minus small m v. Just trying to see what is the pattern we can see here. Okay, so from the first one we are getting capital mv1 is small mv. From the second one we are getting capital mv2 is equal to 2mv minus mv2. That's not going to make too much sense. The third one, we'll get capital mv3 is equal to okay, now I'm understanding. Okay, Just give me a moment, I'll explain. Right. Yeah, so I think what we'll do is now, here's the idea. Let's look at this momentum. P1, that is A's momentum after the first time he throws, that is equal to mv. Okay. Then let's look at this momentum. Not A's, but A plus the ball's momentum. How much that becomes? That becomes this mv1 plus mv, no?
Sir,
Because this momentum is equal to this. Got it?
Yes, sir.
Okay. Then this momentum, now this becomes how much? So this is actually our m plus mv2, but I won't worry about that. I'll just think about these, how much they are. Okay. So this momentum is going to become how much now? It is going to be P2 plus mv. Is it?
yes, sir.
Or it is, no, wait. It is V plus V1, no? V plus V2. Because the impulse that is given the ball is not mv2 now, no? It is like this. Okay. So I think now we will see a pattern forming. So next time he receives the ball, what is happening? The ball is coming at this velocity and he is having this velocity v3, no? Okay. So this whole thing's momentum is P4 now. So P4 is equal to mv3 plus mv. So now do we see a pattern forming here? I'm just writing the series here. P1 is mv. Okay. Then P2 is what? It is P1 plus mv.
Yes, sir.
Okay. Then P3 is like P2 plus mv plus v2. And how we'll get v2? We'll get v2 from this because we know that this P2 is m plus mv2. Okay. Then next time we know that P4 will be mv3. Okay, which is basically P3
Yes, sir.
plus mv. And that, so now you can see now we are getting, so if you break these up also into every time he's throwing and every time he's catching.
So we don't really need to consider P3 because the velocity that we have to find of A consider only those when it's released the ball towards B.
Yeah. So what will happen is in the nth iteration, after releasing the ball, A's velocity becomes more than 5. So the ball never comes back to him.
Yes, sir.
You understanding, no? Okay. So let's look at two things. A is throwing the ball and he is catching the ball. Okay. So first time A throws the ball, his velocity becomes P1 by capital M. So that is mv by m. Okay. Then first time A catches the ball, his velocity becomes this. Then second time A throws the ball, his velocity becomes how much? It becomes P2 plus mv divided by m. And P2 was how much? It was P1 plus mv. Now you see, now this is a pattern forming. Okay. Now when he throws the ball, sorry, when he catches the ball the next time, the velocity becomes P3 plus mv divided by m. And P3 was P2 plus mv plus mv2. Not be this. So P1 was mv, so this will become 2 mv plus V2 was this. No? Okay, so now if you compare this term with this term, no, you can see there's an addition of m by mv. You understanding? Huh? P4 is equal to V3 plus m by m into v. Just compare these two terms. Okay, so this way you will be able to form some kind of a pattern, I think.
Sir, this question is really lengthy, sir. Will we get this kind of question in JEE Advanced?
Yeah, I mean, JEE Advanced, you can get questions which are lengthy, which you either leave out or you invest the time in it.
Then, sir, if you're done with all the other questions, then you feel you have time, then you solve these kind of questions, no?
No, the thing is like when you're analyzing the question, if it strikes you that, okay, there is some kind of pattern forming and it's a matter of just investing the time in it, whether it is 2 minutes, 2.5 minutes, 3 minutes, and you will get it, then you go for it. If you feel that, no, you're not able to understand what pattern is happening, then you leave out the question now. You come back to it later if you have the time.
Okay, sir.
That kind of judgment you have to develop gradually. Okay, it will not happen in every other question. It will happen in maybe 10% of the questions or 7% of the questions in JEE Advanced, but there will always be few of those questions which are like traps. If you don't get the pattern soon enough, then you will end up wasting time. So you have to make that judgment call that are you going to invest the time in it or are you going to let it go? Okay.
Okay, sir.
Okay, anyway, what was the next question we are going to do after 38?
The 40, I think.
40, no? Okay. Let's come to that. This is the question which has a different concept. So gamma decay process, okay, the internal energy of the nucleus decreases and a gamma photon of energy E. Okay, so I'll have to explain a whole lot of things which are based on modern physics concept actually. So first of all, we have to understand how and what is a photon and how it is different to a particle. Okay. So I'll just give you a brief background because We'll be studying this in more detail later in modern physics. Okay. So a gamma photon, which is mentioned in this question, in 40th question, is just one of the many types of photons possible. In general, what is a photon? It is a quantum, or we can think of it like a packet of electromagnetic energy. So by electromagnetic energy, we mean that the electromagnetic energy of an electromagnetic wave. And electromagnetic waves are of various types. There are radio waves, cosmic waves, there are microwaves. Okay. There is visible light, ultraviolet, infrared, there is X-rays, and finally there's gamma rays. So gamma rays are, okay, so we'll come back to how they're different also. Okay. Now, what properties a photon has? A photon is a quantum of energy such that its rest mass, that is the mass that you can measure for something when it is at rest, is 0. So it is not a particle. Therefore, the photon is not a particle. That's why we give it a separate name, because by definition, a particle must have mass. So we give it the definition that it's a quantum of energy, but it's not a particle. Okay. But a photon has two important properties. It has energy, a finite defined amount of energy, which you might have heard this term earlier, hc by lambda, or hf, where f is the frequency of a lambda is wavelength. This you might have seen in structure of atom in chemistry.
Yes, sir.
C is speed of light. Okay. And the other property it has is that it has linear momentum. And the fact that it has linear momentum, that means whenever photons are involved in collisions, there is impulse. Okay. So don't worry about where these formulae have come from right now. Okay, we'll discuss some part of that in modern physics. Okay. So even in modern physics, our discussion is going to be quite superficial because we don't get into quantum mechanics at this stage at 11th, 12th level. Okay. So anyway, so what we need to understand here is that this gamma photon is not a particle in the traditional sense. It is a packet of energy, but it has momentum, and that momentum is given by E by C, or that's the same thing as h by lambda. Okay. So now what happens is that every time a nucleus undergoes some kind of a nuclear reaction, okay, like you might have heard about alpha decay, beta decay, those kind of nuclear reactions, invariably it emits a photon also, or a pair of photons or whatever. Okay. And in the process, there is momentum conservation. So for example, I'll give you a more interesting example than the one they're given here. Let's take the case of a beta decay of some nucleus. So let's say the nucleus has this thing, you know, what we call mass number A and atomic number Z. So this is a nucleus which is having Z protons and E minus Z neutrons. Now, what a beta decay involves is that a proton converts into a neutron converts into a proton plus an electron. Okay. So beta decay. Now, why a beta decay occurs? Now, that is something which we can't really prove theoretically. Okay. But we understand from practice that certain nuclei are more stable than other nuclei. So the ones which are unstable are called radioactive nuclei, and they stabilize by undergoing these kind of decays. Okay. So suppose we take the example of a beta decay, where a beta decay involves a neutron converting into a proton plus an electron. Okay. And this electron gets ejected. from the nucleus. Okay. But along with that, there is also a photon which is released. And this is a gamma photon, which also gets ejected. So now we are worried only about the momentum conservation part in a situation like this. So as I said, let's not worry about why the beta decay happens and what is the mechanism and all that, but let's just visualize. So first of all, if we just think in terms of the physics of the nucleus, we have Z protons and A minus Z number of neutrons. But as this is undergoing the beta decay, what is happening is that one of the neutrons in the nucleus is disintegrating and converting into a proton plus an electron, and that electron gets ejected from the nucleus. So once that happens, your Z has changed. No? So the Z has changed means the nucleus has changed. It's become a nucleus which has Z plus 1 protons, but same mass number, because total number of neutrons and protons is remaining the same. So it has converted from a nucleus which earlier had Z protons plus A minus Z neutrons to something which now has Z plus 1 protons and A minus Z minus 1 neutrons. Okay. And plus an electron plus a photon. So these are ejected from it. Okay. So this electron only is called the beta particle actually. This will be an electron which has comparatively high kinetic energy. So it's a fast moving electron which gets ejected. That is called the beta particle. Now let's try to visualize this from the momentum perspective. So what is happening? A parent nucleus X was at rest, let's assume. And suddenly when it disintegrates, what happens? It forms the daughter nuclei, which ejects, let's say, an electron like this. Okay. So the electron has a certain amount of momentum. And it also ejects a photon, which we show with this kind of symbol. So this also has a momentum. Okay. But the system momentum will remain conserved because there's no external force. So you will realize here that the daughter nucleus will have to have some recoil velocity. It will have to have some B prime like this. So what will happen is that this system's total momentum will be conserved. So it will be 0. So mass of the daughter nucleus into whatever velocity it has, vector sum of that with mass of the electron into velocity of the electron plus the momentum of the photon, this vector sum will have to be 0. So this is a typical application of momentum conservation in nuclear physics where we are seeing a beta decay. So this particular question that they've given you, it's a simplified version of this. In this, we are not considering any beta decay. What we are just saying, let me go through the question again. Yeah. Is in gamma decay process, the internal energy of the nucleus decreases and a gamma photon is. So this is a hypothetical example. Actually, something like this never happens. A nucleus will on its own never emit a gamma photon. The gamma photon will always be emitted as part of some other nuclear reaction. So it is never unaccompanied. It's always accompanied with some other change. So either a beta decay or it can be an alpha decay also, for example. So if it's an alpha decay, it will be something like this. Such a nucleus will form a new nucleus which has 2 less protons and 4 less nucleons because it emits a helium nucleus, which is 2 protons plus 2 neutrons. And this helium nucleus is only called the alpha particle. But always any such reaction is also accompanied by a gamma particle. So again, here what is happening? Our X, the only difference is now the particle it is emitting is not an electron, it is an alpha particle. So that will have some velocity, let's say V1. This has some recoil velocity, let's say V2. And along with that, a photon is emitted, a gamma particle. So again, that same reaction, that same momentum equation will hold over here, that the mass of the daughter nucleus into its velocity plus the mass of the alpha particle into its velocity plus the momentum of the gamma particle, this vector sum has to be 0 because the parent nucleus was at rest initially. So this is actually what happens, how we apply momentum conservation in these kind of nuclear reactions. Now, in this question, they've given you an oversimplified situation where something like this is happening. It is just becoming X only, but plus a gamma force. So this never happens. It's actually always, but it's losing energy in comparison.
yeah.
So
The photon actually gets a velocity of 2c. Yes, sir. So I got the right answer, but sir, the photon, no, it actually gets a velocity of 2c here, which is not possible.
wait. How are you saying the photon gets an
Sir, they've given
velocity of?
kinetic energy and they've given us momentum, right?
Okay. So see, so if the energy of the photon is E, the momentum of the photon here is 2E
Yes, sir,
by C. Sorry, E
M-
by C. Yeah.
Sir, I expressed M and V in terms of E and C because they've given us two equations. So accordingly, V becomes 2C.
Wait. E by C I cap, let's say. This is a photon. So what will be the momentum of this? Momentum of X will be minus of that, no? Because the total momentum has to be 0.
Yes, sir.
So the momentum of the nucleus will become minus E by C I cap.
Yes, sir.
Okay, then what?
No, sir,
Find the-
I just said, okay, half mv square of this thing is equal to E and mv is equal to E by C.
half mv square of what, beta?
The photon.
No. Okay. This is where it's different, na? Photon doesn't have mass, na? So it doesn't have kinetic energy like that. It has electromagnetic energy, which is hc by lambda, and it has momentum, which is h by lambda. You understanding the point, beta?
Yes, sir, I treated it as a particle.
That's the difference. Okay, so that's why we have to be careful. So this was initially at rest and at a higher energy state. Now this high energy state, you can just think of it like, you have studied in Bohr's model of atom, that atoms can undergo transitions, from higher state to lower state, because the electrons are undergoing transition from a higher energy orbit to a lower energy orbit. So similarly, nuclei can also undergo transitions because the subnuclear particles are also in different quantum states. So they can undergo a transition from higher quantum state to lower quantum state. And in the process, this remains X only. It's not transitioning into a new nucleus, but it's coming to a lower energy state.
Yes, sir.
So let's say that lower energy state is E2. Okay, and this higher energy state was E1. But in the process to come to the lower energy state, what's happening? It's emitting a photon or a gamma photon. Okay. So because it's emitting a photon which has momentum in this direction, it will develop a momentum itself in this direction. Okay. So momentum of X plus momentum of the photon
0.
should be 0. So their magnitude should be equal. Okay. Now, as far as the photon is concerned, photon, remember, has energy equal to hc by lambda, and it has momentum equal to h by lambda, but it has rest mass equal to 0. Okay. So dx, the momentum of this particle, this nucleus now, is becoming E by C or h by lambda. Okay, this is the first thing we understand. Okay. Now what is happening? The total energy has to be conserved. So this higher energy state, it is converting into a lower energy state and releasing this much energy. It is releasing the kinetic energy of the X nucleus plus the photon energy. So this is where it will come in. Okay. So if the X nucleus has momentum equal to this much, what about its kinetic energy? With this?
Yes, sir.
So E1 will become equal to E2 plus, so that is going to be now E by C whole square divided by 2 times mass of that nucleus. Whereas energy of the photon is already this much. Okay. So this is this plus plus. So this quantity now actually becomes the energy difference, E1 minus E2. I think that is what they've asked, no?
Yes, sir.
So that becomes this, okay? Becomes E square by 2mc square plus E. So does that have to be reduced in terms of anything else or no? So yeah, so we have to give the answer in this form only, in terms of mass of the nucleus and E of the photon. So it will be like this, okay? So this is the concept we have to use here.
So why did I get the right answer when I treated it as a particle?
I don't know, I'll have to examine that.
Or sir, maybe I kept on working even though I got B is equal to 2C. So it worked.
Yeah, maybe. But see, as far as momentum conservation is concerned, its effective behavior is like a particle. But the problem happens when you do the energy equation. Because it
Okay,
does
sir.
not have any equivalent kinetic energy, no? Because it. Okay. So this was question number 40. Hope this is clear.
Yes, sir.
Okay, now we had one more question, 50 something, 52, was it?
Yes, sir.
Okay. So we'll just go through question 52.
The 52 is connected to 51.
51. Okay, so let's go through this
And
series
NEET
of
is connected
questions.
to
Acha, it's a whole series of questions, no?
yes, sir. 50 onwards.
50 onwards, yeah. So yeah, this thing, no? Yeah, this is a very nice series of questions. Let's discuss. Okay. So let's look at all the different situations. Two blocks connected by a spring. Now in the first case 50, we are giving one of the blocks M2 a sharp impulse. So sharp impulse means, like, imagine it's been hit by some other collision or something. So it immediately develops a velocity V0 while M1 is at that moment at rest and the spring is at natural length. So you have to find VCM and maximum elongation. I'm sure you worked that out, right? 50th question. VCM you will get by momentum equation, right? And maximum elongation ke time pe what will happen? The velocities of M1 and M2 will become equal, like one of those questions we had discussed. Okay. Now in 51, you have the same initial situation, M1 and M2 connected by a spring, which is unextended and all that. But instead of giving a sharp impulse, you are applying a constant force. So you have to find the maximum elongation. And in 52, M1 is pulled by F1 and the other block is pulled by F2. So find the maximum elongation. Okay. So both these questions will involve the same kind of method of solving. So let me just solve 52, because 51 is like a version of that only, but with only one force instead of two forces. So let's see what concept we'll apply. So this is where we will learn how to apply dynamics in center of mass frame. So let me explain what that means. So this is the initial state of the system. Both the blocks are at rest and the initial extension of the spring is 0. Okay. It's a smooth surface. Now we set the system into motion by applying forces like this. So let me also take a numerical example so that we can solve it numerically also simultaneously. Let's say M1 is 6 kg, M2 is 3 kg, and F2 is, let's say, 20 newtons, and F1 is, let's say, 11 newtons, and the spring constant is, let's say, 20 Newton per centimeter. So we have to find the maximum extension of the spring. So in a general question, I'll have to make an assumption, but in this case, I can see that F2 is greater than F1. So the center of mass of the system will accelerate in which direction? In the direction of F2, assuming that F2 is greater than. So this becomes this. This is the acceleration of the center of mass. So for this example, acceleration of the center of mass will become how much? 1 meter per second square. Okay. Now, once we have found the acceleration of the center of mass, what we'll do is we'll get into the frame of the center of mass. Okay. We'll look at FBDs of M1 and M2 in the center of mass frame. And that frame will become what kind of a frame? It will become a non-inertial frame. So this is a particular technique of solving this problem. So if I'm seeing this from ground frame point of view, what I'll see is that after some time, the spring has got maybe extended. Okay. And this is having some acceleration. This is having some acceleration. But instead of this, I will now get into the center of mass frame. So I'm in the center of mass frame and I'm traveling with this acceleration, which is F2 minus F1 upon M1 plus M2, which for my numerical example has become 1 meter per second square. So at some time t, in my frame, what is happening is this block M2 and this block M1, they are having what all forces acting on them? They are having F2 kx, F1 kx, but along with that, they are also having pseudo force M1 ACM and M2 ACM. And in my frame, with respect to the center of mass, that is, let's say they are having accelerations A2 and A1. So A2 and A1 are acceleration of the blocks relative to the center of mass. So let's write our FBD equations. So we have F1 plus M1 ACM minus Kx is equal to M1 A1, or we have F1 plus F2 minus F1 upon M1 plus M2 into M1 minus Kx is equal to M1 A1. So you see that with F1, I'll have M1 M2 minus M1. So I'll just have M2. And with F2, I'll have M1. I'll have this kind of a term. Or if we write this out numerically from above, we would have had 20 minus M1 was how much now? 6. And ACM was 1 minus Kx is equal to 6A1. We'd have an equation like this.
Sir, we know K also.
We can put K also, but for the moment, let's just write it like this. So this would become the equation for E1. Okay. Now, similarly, let's write the equation for the second block. For the second block, we have F2 minus M2 ACM minus Kx is equal to M2 A2. So we have F2 minus F1 upon M1 plus M2 into M2 minus Kx is equal to M2 A2. So this time you can see F2 will have similarly that term F1 F plus M2 F1, that same term you will get. we get this equation. You see, this equation and this equation are symmetrical. Or numerically, if I solve this, let's see what we'll get. So F2 was 11, sorry, 20. Oh, I made a mistake here. This one was not 20, this one was 11. So this should be 5. Rest of the things are okay, yeah. Here this will become 20 minus
3.
3. Why we are getting different terms?
In the first we had M2 F1 plus M1 F2. Now we're having M1 F2 plus M2 F2.
The same, no, beta. Wait, just a second. Everything correct for us here. Acceleration of center of mass is 1, that's okay. And oh, I think I've taken the direction of pseudo force wrong in this equation. I mean, here it's okay, but here I've subtracted. It should be added. Yeah. So now we'll get the correct one. Right. So this term now working out correct now. So F2 is 20, M2 is 3, and ACM was 1. So this minus KX is equal to 3A2. So we're getting that equation. We're getting 3A2 is 17 minus KX. Okay, so now if you relate this with what you had learned in, going back a little bit to spring mass systems and work energy, just think of something like this, that if you had spring attached to a wall and a block like this, and initially your x naught was 0 and your u was 0, and then we started applying a force continuously on this, a constant force. What was the condition for maximum extension? Do you remember that?
The block comes at rest.
But what relation that had with acceleration of the block? There was a symmetry, no? It has maximum acceleration at this point, right? Then it has equilibrium at some point, and then the maximum extension, it has equal and opposite acceleration. You remember this part? Equilibrium point is the midpoint of the two extremes. People, none of you are answering, so I'm not understanding. Do you remember this part or not?
So what is that equilibrium point at A equal to 0?
Okay, so that means you don't remember. Okay, let's discuss this. Okay, because we are going to use that now. Okay, we are not going to get into work energy here. We can get into work energy, but basically see what is happening. This equation is something like this, that M1A1 is equal to, you can say, some equivalent constant force minus Kx. And the other one is also showing you that M2A2 is some equivalent constant force minus Kx, where that equivalent constant force is this term M1F2 plus M2F1 upon M1 plus M2, which in our numerical example was working out to be 17 newtons. Okay. Now the idea is that whenever we have a system which behaves like this now, we will see that acceleration A1 becomes 0 when x is equal to this equivalent constant force divided by k, and simultaneously A2 also becomes 0. It's the same. So now from this we should be able to directly conclude that maximum value of x will be twice of this. Now how will we be able to conclude that it will be twice of this? Because this is a shortcut we are using. I'll show you next. Okay, so here I'll show you this. So F max will come out to be twice of this term, M1 F2 plus M2 F1 upon M1 plus M2, and there's also K. So it'll be like this. So this is the answer we'll get. Now I'll show you the logic of why this happens, that wherever the acceleration becomes 0, that value of X is actually half of the maximum. Okay. Has anybody been able to connect this concept here? Why this is the case?
Yes.
Okay. So recall this problem, which I'm sure all of you have done. When I release the block from this situation, what is the maximum extension that I get? Yes, Siddharth, you got the point. Okay. I get 2 mg by K, no?
Yes, sir.
Okay. So if you look at B and A at some point of time, you can see that you have the relation half mv square, okay, is equal to mgx minus half kx square. That is a work energy relation. And from this you get that V is 0 when X is maximum. So from that you get X maximum as 2 mg by K. Okay, but at any point of time you also see that the acceleration of the block in the downward direction is mg minus kx divided by m. So you can see that acceleration is 0, that is, it reaches the equilibrium point at x equal to mg by k, which is half of the maximum extension. So why that happens is because always systems like this are symmetrical. They actually go into oscillation. Okay, so if these are the two extreme positions, u equal to 0 and v equal to 0. So when v is equal to 0, x is maximum. When u was equal to 0, x was minimum, which in this case is 0. Okay. The equilibrium point will always form the midpoint of these 2 points. This is where v will be maximum and x will be equal to the average of these two. In this case, x minimum is 0, so it will become this. So this becomes what we call the amplitude of the oscillation. So 2a is equal to this x max minus x min. So this is the trick we are using. If we know this trick now, we don't have to solve the work energy relation. We have to just solve the dynamics. From the dynamics, we are getting this acceleration, for example, in this case. So from this, we know that acceleration is 0 when x is equal to mg by k. So from that directly, we know that x maximum will be mg by k into 2. So that same concept we are applying over here with these equations. So that is the efficient way of solving this problem. The other way of solving this problem is you go back to those FBTs in the non-inertial frame and you apply work energy theorem to them. But you will also have to consider work done by pseudo force, and pseudo force is a constant force here. So in the non-inertial frame of the center of mass, the two blocks should come to rest simultaneously at the moment when the spring reaches maximum extension. Okay, are you people understanding that?
Yes, sir.
Yes,
Okay.
sir.
So as you know, as an exercise in problem solving, you can try by that work energy method also. So what you do is in this diagram, you assume that this block has moved by x1, that block has moved by x2. So m1 x1 should be equal to m2 x2. Okay, and individual work done by each of the three forces, individual work done by each of these three forces, and then apply work energy theorem. Okay, yeah. So here also what will happen is that as you're pulling the system with these constant forces f1 and f2, while the center of mass is accelerating, but in the center of mass frame, the system is oscillating. It's going from natural length to maximum extension, back to natural length, back to natural maximum extension, and so on and so forth. And every time it goes between minimum length of the spring, which is the natural length, to maximum, which is L plus X maximum. In between, it reaches the situation where in that frame, the kinetic energy of the blocks is maximum and the blocks are in equilibrium. So this whole problem, like this vertical spring mass system now is, it's getting translated to a system in a non-inertial frame where the two individual blocks M1 and M2 are doing oscillations like this, and the oscillations are synchronized. So when M1 reaches the furthest point on the left, M2 reaches the furthest point on the right, and vice versa.
Sir, but at equilibrium, the spring force is balanced by the MG, so it should be at rest.
No, that's the difference, beta. Its acceleration is 0. It's not at rest, because by then
Okay,
it's
okay.
gained kinetic energy, na? So that's why it goes past the equilibrium point. Na?
Yes.
So basically what is happening is from x equal to 0 to x equal to mg by k, that is the equilibrium point, the speed of the block is increasing because it's having positive acceleration. And then when it crosses the equilibrium point, it starts decelerating because now kx is dominating over mg.
Yes, sir.
And it just so happens that the symmetry of the problem is such that the amount of distance it traveled while accelerating, it will travel the same distance while decelerating. It's like a mirror image. Okay, and still further in the chapter of simple harmonic motion and oscillations, we will see how to find the time period of such a system also. So then we will see a third method of solving this type of question, and that is the simple harmonic motion method of solving, by solving the equations of SHM. Okay, so we can solve it by work energy method as I described you, but I didn't show you the equations because they're lengthy. Or we can solve it by dynamics like I've done over here, but using this trick that when we have an oscillating system like this, the maximum extension position will always be double of the equilibrium position. Or you can say that the two extreme positions, their midpoint is the equilibrium position. So here the extremes are natural length and maximum extension. So the midpoint of those two is the equilibrium position. So I have found x at the equilibrium position. So I know that the maximum value of x will become double of that. That's how I got this 2 times F equivalent divided by K. Okay. And the third method that we'll study will be when we come to oscillations, and we'll study how to write the equation of SHM for the two blocks and find out not only the maximum displacement by amplitude method, but also the time period. These two methods that we've discussed right now, dynamics and work energy, we can't solve for time, that how much time it takes for the blocks to, or how much time it takes for the spring to go from natural length to maximum extension and all that. We can't do that. But when we come to SHM, we'll learn that also. Okay. So people will conclude today's session here. We have another session on Wednesday, I think, right? Or Thursday, one of these days. So we will devote some time in that session also to discuss the doubts. And as I told you, I will send you the answer keys. We're working on, actually that answer key was not available, so we're making it. So hopefully by today or tomorrow, the answer key will be available to you for the module.
Sir, at the start of the lecture, someone mentioned something about your assignment on system of particles. Sir, where had you sent it? I'm not able to find it in our group.
This was an early assignment I had sent, beta, when we were doing center of mass. There were 2 assignments I had sent together. One was revision of circular motion and the other was this. And if I remember correctly, I might not have sent the answer key of that assignment.
Oh,
Yes, so there's no answer key for that.
No, because I wanted you people to solve, and then so I'll resend the assignments, both the circular motion one and that one with the answer key. And after we finish discussion of the doubts of the module exercises, we'll also have a revision exercise for center of mass. Okay.
So can we also ask circular doubts in the next class?
You can, but I don't think we'll, I mean, what I'm thinking is that it'll take time to discuss the work, the system of particles doubts itself. There'll be quite a few from the module. Okay.
Sir,
But
actually,
anyhow,
it's
now,
just a couple of doubts from the DPT we gave recently.
okay, we can discuss maybe. Okay. In any case, now, like, we'll have more and more regular physical doubt sessions also in every center. So you can start discussing those also.
So when will you be in Kharghar?
I think I'm there on that day only, Thursday, if I'm not mistaken. I have to check the schedule.
Okay.
Then sir, we have offline class selectively for Kharghar people on Thursday.
Yes, you have.
Okay, sir.
Okay. Okay, people, that's it for today's session. Then wish you all the best.
Thank you, sir. Bye, sir.
thank you,
Sir.
sir. Bye.